Hello viewers. So today I would like to begin a video series about an elementary introduction into the world of machining. And machining in itself is a very broad term because it is encompassed by dozens of different types of processes and styles of machinery. But here in a job shop such as ours, most generally found, the bulk of the work is completed by two different types of machines. The first being a milling machine, which is responsible, as the name implies, for milling, and a lathe, such as that, which is responsible for turning a part. And the difference between milling and turning would be that milling is a process in which you rotate a cutter, such as this one, which is an end mill, and you make contact to your stock to remove material as desired. And a lathe turning is where you rotate your workpiece and make contact with a static tool that removes material from your stock, such as this. The cutter does not move, but your workpiece does. But in this particular video, we are going to be focusing on what is and how does a 3-axis CNC machine work and operate, and what does it do. So stay tuned and follow along as I bring you guys to the inside here and just explain the very basics of what we have here. Thank you very much. So here we have our 3-axis CNC vertical machining center. This one in particular being a Haas VF3, and it being a 3-axis milling machine means that this machine has 3 possible axes of movement. And just to demonstrate, those axes are your y-axis, upon which the table will move to and away from you. You have your x-axis, upon which the table moves side to side, and of course you have your z-axis, upon which your tool will move up and down. And these 3 axes are located upon something called the Cartesian coordinate plane. So I'll try to explain it and use your imagination here, guys, but basically the Cartesian coordinate plane is a you could imagine it as a map or a plot, and if you could imagine the y-axis just as a line and then your x-axis as a line, and the point at which they intersect would be your 0, 0, or your origin point. And along each axis, if you would imagine an increment, and for the sake of simplicity, we would just do increments of 1 inch. And you'd have your 1, 2, 3, and to the left of your x or the y-axis along the x, you would have your negatives. You'd have your -1, your -2, and the same goes for your y. You'd have your 1, 2, and then you would have your -1, -2. And along this coordinate system is how and where the machine positions itself along. So imagine in your program a coordinate would be called out of 3, -1. So the machine would go 3 increments in the positive along your x-axis, which comes first in a coordinate, and then it would go -1. And at this point in this coordinate system, it would come to this point. And when you take a large series of these coordinates and put them together in a program, you can create very complex geometry along which the machine will move upon and create the features that you desire and program into your machine. So it's as simple as that, and of course it gets very much more complicated, but if you guys have trouble understanding that, I highly urge you to, do your own research and find out more about it. But anyways, on something like a 5-axis machine, you would have 2 more axes of available movement. So that would be your C axis, around which your table could rotate like that. And depending on the type of 5-axis or the design of your 5-axis, you would have either your A axis, which would allow your table to rotate like that, or you would have your B axis, which would allow your table to rotate like that. And those would be relative to your Y and to your X. But anyways, those are the planes of movement along which a CNC machine, or really any manufacturing machine, moves along generally. Nextly, I want to quickly cover the componentry of a milling machine. So here, of course, you have your work table, which is the table that is a part of the machine, and upon this table you mount your fixtures, such as these vices, or you have things like rotary tables, which can add that extra axis of movement on something, even on a 3-axis machine, in theory making it into a 4th-axis machine. And they have automated rotary tables. They even have automated 5-axis or an additional 2 axes rotary plates. But you can also use things like plates and studs and bolts and clamps, whatever you can really come up with using your experience and creativity. But the purpose of all of this is to hold down and orient your part in a rigid manner to allow your machine to work upon your workpiece. And nextly, we have our chip auger, or in some machines you'd have a chip conveyor, of which the purpose is to evacuate the chips or the byproduct of your material from your machine. And then you have your ATC, which stands for automatic tool changer, and that works to transfer your tools from your spindle into your tool carousel, which is where the tools are housed. And spindles vary in different styles. This particular one is a Cat 40 spindle, and Cat 40 specifies the geometry of the taper of this tool holder here. And between machines and manufacturers, they vary. The larger your taper is, the more rigid, the more workload and torque you can apply to your tool in your programming to take bigger, faster cuts. But other examples of different styles of taper would be a Cat 50 or things like HKS 80, HKS 100. But in your standard, typical entry-level to mid-level CNC mill, you usually will find a Cat 40 taper. To continue on, this is a CNC machine, and CNC stands for computer numerical control. This here being your computer control. And it serves as basically the brains behind the mechanical function of your machine. And as you go from manufacturer to manufacturer, things like the design and the user interface will vary, but generally CNC machines and CNC controls, they recognize and are operated by a computer or software language, which consists of 2 different codes, and those codes being your primary codes, which are your G codes. And G codes, if I were just to explain it in a way, I guess, that puts it across the table, would be that G codes, they control the numerical functions of your machine. Things like positioning of your table, the positioning of your tool along those axes that we spoke about, and things like specifying your tool geometry, the position of the tool along your table, and also specifying things like which work coordinate system that you are working in and things like that. And your secondary type of code are your M codes, and M codes they control the miscellaneous functions of your machine. Things as turning on and off your chip auger or your conveyor, things like turning on and off your coolant, or performing tool changes. And between those two styles of codes are very many different numbers that specify different functions. And with that you can basically create any type of tool path that you desire. So just to show you as an example, we're going to go here to list or memory, and you can see we just have this random program already called up. And just an example, you can see in this line of code here you have G00, and G00 will tell us, will activate the rapid movement of the machine, which is basically rapid movement to position in your table or your machine. That's the function of it. And then you have G90, and that calls upon the absolute position command, which will call up not your operator axis or position, but the absolute position of your G54 work coordinate system. And G54 is a work coordinate system upon which you will program your 00 to, and that's from where the position of where the machine will work and execute your entire program from. And just to go back here quickly, and then it tells us in your G54 work coordinate system, it will be moving to your X minus 1.5 inches and your Y0. So that will be the position along that Cartesian coordinate plane that we talked about earlier. And here you have MO3, which will activate your spindle at a revolution of 800, or at a speed of 800 revolutions per minute. And your CAM, or computer aided machining software, will basically take your programs that you write in the computer, and it will write a whole list of these codes from, and you will be able to have a program that basically allows you to work in any function that you want from such a machine. But anyways, not to talk too much, thank you guys for tuning in for this, I guess, crash course of what is and how does a 3-axis CNC machine work. Basically, I would love to get more into the depths of theory if you guys are interested, and also it would be a huge honor and a huge help to me if you guys could hit the like button. Helps my channel substantially, and if you feel compelled to do so to see my future videos and machining, just the whole job shop lifestyle in general, hit that subscribe button. And if you are really feeling up to it today, hit that notification bell as well, and leave a comment down below. I love and appreciate any and all interaction with my channel, and I will do my best to get back to you guys. But anyways, thank you very much for watching. Have a blessed day.